going to talk about structural damage. Now, I've changed the title to Procedures Following Observed Damage. And the reason I did that is because structural damage caused by vibrations is extremely, extremely rare. We keep our vibration limits so low that actually causing damage to a structure, as I referred to earlier, would take usually much higher vibrations. And so I'm going to talk about both structural and non-structural damage and what we do to evaluate it. And what I did was I looked at your construction manual, and there is a section 10.83 called Damage to Historic Structures. And if you haven't seen it yourself, I thought we would just read through that first, and then I'll give you kind of maybe a boiled down version of kind of a procedure to follow once we've identified damage. The contractor is to exercise all reasonable care to protect historic structures from vibration damage. The contractor is required per the SP to conduct daily inspections to determine if any changes to cracks or damages have occurred. Contractor is also required to conduct a survey of damages following an alarm. That's an exceeding event. So if what Bob just described happened, the contractor should go out and check for any damage, right? Now, the contractor must, if there's an exceedance, if it results in damage, the contractor must notify, and this means the resident engineer, right? Okay. The contractor must notify the resident engineer immediately of those damages, cease work, right? Stop the work, and let's figure it out, and then verify that the monitoring system is correct. And then here's the kind of the action plan. Notify OLE, that's your environmental group, right? That includes a lot of you folks. That will in turn notify the SHPO. Notify the contractor of any mitigation actions, approve or disapprove. So this is, they need to change their methods, and you should be aware of what those changes are and approve them or not. And then here's what I want to just kind of go into. It's the contractor's responsibility to follow the instructions of the OLE to repair the damage to the historic structure due to exceedance. So how does that happen? What should that repair be? That's really the subject of this presentation, okay? And here's how I kind of boil it down. This is really an overall blueprint of what should happen. And this is really my only slide, and then I'll get to an example. Well, I've got one more slide after this. But first and foremost, I think it's important to clarify that it's the contractor's fault. You may not need to come out and say it quite that bluntly, but it's in what I just read that it's their fault. And that will set the tone for everything that happens next. Because you all know, I mean, Jim this morning spoke about the Kingsway project. I mean, this can get very serious. And so clarify that it's their responsibility if they exceeded the limit. The contractor must change their methods and convince you that their methods are really going to be lower energy so that this doesn't happen again. And then there needs to be an inspection by a qualified engineer. And I would like to suggest that you categorize the damage into these three categories, and I'll define those on the next slide, because these are really the definitions that have been used in the vibration literature way back, well, from the U.S. Bureau of Mines testing. And if you can use these same definitions, what you've done for yourself is you've protected yourself in the event that this becomes litigious or controversial, because the limits are set up to prevent even what kind of damage? Threshold damage, and that's got a very specific definition in the literature, and there's research behind it. So if you talk about threshold damage, not just damage, because when you say damage, people think serious, they think structural, they think, you know, damage. Threshold damage is the very first signs of any effect. Hairline cracking and plaster, widening of old cracks, and so on. Okay. Now, if it's non-structural damage, which is usually going to be in the threshold or minor category, the contractors should repair it to a pre-event condition per your instructions. And that's going to vary. I mean, if it's a simple crack in drywall, that's very simple. The contractor follows standard construction procedures. We know how to fix drywall, right? If it's a crack in a historic building, there may need to be direction from historic preservation sources. So that is kind of going to be case dependent. But I'm going to talk about structural damage, and I'm a structural engineer, so I can speak to that. Usually then you're going to need to have repair procedures and specifications. Again, it's going to be a very rare case, but that would be what you would do in that incidence. Let me define those categories. This is straight from, I believe it was originally in the USBM report. It's quoted a lot, but threshold damage, opening of old cracks, Formation of new plaster cracks, that's threshold damage. Maybe dislodging loose objects like bricks inside of a chimney or something, but it's just the very beginning of any kind of an effect. Minor damage, and remember, do you remember the numbers? I mean, threshold damage never happened below 0.5. Minor damage was like 3 or 4 inches per second before this started to be observed, and major up to 8. So this is things like cracking a brick, maybe cracking windows. Major damage would be foundation damage or something to the structure. All right, so let's keep those definitions in mind. Now, if structural damage occurs, there's a series of things that a qualified engineer should do. Let's take a case in point. Well, Bob had a good example with the Pierre Hotel. Remember that? So they tried to jerk out that casing. Liquefaction resulted. Settlement of the building. I mean, it doesn't have to be liquefaction. It could be some other settlement. What would you do as an engineer? Well, I think the first question is the thing stable? Is public safety at risk? That's the first decision that should be made immediately on the site. And shoring might need to be put up. Some sort of bracing might need to be put up. So that's a quick decision for public safety. And then it's an investigation, okay, of the cause and significance. I would challenge you to think about, is the damage direct only? That is like what you can see, what you see is what you get? Or is there something kind of invisible that we need to think about? What might that be? Well, we got to use these charts. Let's say we have a foundation. Here's exterior grade. This is our building, right? We got a slab on the inside like that. So let's say that something we did out here shook the ground, caused settlement of this foundation. So this is the dirt. This is the inside of the building. What might you be concerned about? This is dirt as well. What might you be concerned about inside this building if this settled? I would be concerned about potential voiding as a structural engineer right there. There might be a void there that developed due to foundation settlement, you see? And that might not be visible. So an experienced engineer is going to think about these kind of things. What might you do? It's indirect damage, but it's damage. It needs to be fixed. I mean, if they come and put some heavy shelving here in the future, your slab might crack and fall down. So we would, do something like mud jacking, void filling, that kind of thing. So that's indirect damage. So again, kind of keep your thinking cap on, so to speak, and just don't know. It's not only what you see is what you get. It might be what's a logical possible effect, and then checking to see if it's there. And then determine a permanent repair. Typically, you're going to need some drawings and specs if it's structural damage. I would say effective. That means restored to a pre-event condition. I would also say practical and constructible, right? Something that the contractor can put in pretty quickly and not necessarily take him months on his construction schedule to fix. There may be submittals and approvals needed, and then obviously you're going to need to coordinate it with the property owner. All right, let's take some examples and then we'll move on. It's an important topic, though. It's just going to be encountered quite infrequently. Here's that hotel that Bob referred to earlier, the Pierre. The Pierre. Built 10 or so in Chicago on some pretty questionable soils. So these were the kind of effects that we saw inside the building. Well, clearly this is structural damage. I mean, the building, I think Bob said, settled 1.5 inches. So what might you be worried about? It's not too unlike what I've already said here. I mean, if a building settles that much, there could be voiding, right? There could be things you need to check. So the first thing I would do is get a really good geotechnical engineer to start working with me as a structural engineer. The repair of the cosmetic damage can be pretty straightforward. This was not a listed historic property. You tuck point mortar, you fix floor finishes and drywall. So that's just one example. Bob gave me, or maybe Nate gave me, these pictures. These are 2 projects here in Iowa. I don't know if any of you recognize them. On the left is from a project in Bellevue, Iowa. So there was a crack in some drywall that might have been associated with the construction, a two-year construction period, I guess. So, and then on the right, Bob told me this is from St. Matthew's by the Bridge Episcopal Church. And you can see a very fine crack. I'm not sure if it was pre-existing and documented by us or not, but those are the kind of things that are non-structural, still serious for a historic building, but not really catastrophic. I'm going to walk you through this last example that really is a potential structural concern, and this is that Frank Lloyd Wright Robie House that I referred to earlier. It's a U.S. national landmark. They were doing this kind of construction across the street, and you might remember that our limits were this. Okay, so that's your baseline. I already talked about it this morning. You're already up to speed. 0.2 inches per second was our limit. We knew it was some pre-existing damage. We also wanted to avoid human annoyance. Okay. We installed 2 seismographs in this building, one in the basement, not in the soil. It was actually in the basement inside the building, set to 0.2 inches per second. And then they had us put one up here in the roof cantilever because, they were concerned about the cantilever maybe starting to bounce around. What we found was that the cantilever actually moves a lot more in the wind than it does due to the construction vibration. So that monitor didn't stay in there very long, and it didn't prove very important. That is kind of interesting, though. Bob, did you install that, or did Shinnied way out into the attic, put the transducer way at the tip of that attic? That's pretty impressive. So
I was a lot younger then.
You were younger, and we got paid extra, I think, for that monitor installation. We had some crack gauges and so on, but the finishes were beautiful. Again, just a beautiful historic building. This was our pre-construction survey. I think these are some original Nate Rendy sketches that you're looking at here. There's a plan view on the left, and then wall sections on the, or wall elevations on the right. And what I want to draw your attention to is this south wall. So actually it's on the left, so north is actually to the right, but it doesn't so much matter. But what you see is a lot of pre-existing step cracking. Okay, so brick, masonry, step cracking. Remember, this is our pre-construction survey. So this was all there before the contractor started doing his work. It's a photograph of that south wall with the cracking. I mean, at this scale, you really don't even see it. You might see this separation in the foundation. But if you do look close, these are the pre-existing step cracks that kind of follow right through this zone. So we knew we were there. We knew they were there. The problem was the owner, or I should say the historian in the case, didn't want any crack gauges mounted onto the building because that could mar the historic original brick. I mean, this is a kind of a special sizing that Frank Lloyd Wright has. You know, he loves the horizontal lines, right, in all of Wright's architecture. So all these horizontal lines are really important. So what we did, we used crack comparators and magnifiers to document the width of these cracks before the construction started. And here are the changes over time. We did an interim survey a year later, and then a final survey 2 years later. And what you see is that these cracks grew. Again, while the contractor was doing that work across the street, while we were monitoring vibrations. The question is, why and how important is that? We grew from 50 to 75 mils, 40 to 90. That's 50 mils. That's 1/8 of an inch. No, that's 1/16 of an inch. That's a pretty, significant growth. So how do we make sense of that? At the interim survey, this was the basement inside that location, so the step crack actually kind of goes diagonally here. We didn't put any crack gauges because, well, first of all, they didn't really want us mounting gauges, but it was almost impossible to get one in. But when we saw this growth, we did go ahead and sneak in an avant-garde, I love that name, avant-garde crack gauge between these pipes. And so what you can see is, again, bear in mind, the crack gauge only measures the change from when you installed it to when you read it, right? It's not the total growth, right? Since the building was constructed, it's only the change. And so we monitored the change, and it was about 40 mils, which matched with our measurements on the outside. So we knew that the growth was real. What we were able to do in this case, and this is my last slide, and I'll take a question or two after this, but we had vibration data, and we had survey, careful documentation. The vibration measurements did not exceed the 0.2 limit. We reviewed it again. We scrutinized the data. We didn't go over the 0.2. So what can we say? We know that the research shows that if you don't go over really 0.5 inches per second, there's no reason to suspect even threshold damage. So that's a scientific method to go back to show that. Secondly, we knew the actual pre-existing conditions. We knew there was step cracking and potential foundation settlement in this zone. So we were able to convince all parties that this was in fact inherent to the building's own performance, not related to the contractor's activity. Not that we were trying to defend the contractor necessarily, it was just the truth in the matter. So again, it proves how careful vibration monitoring, good limits that you understand, and then actual surveys before and after, how that can really be a really strong position for you to be in. That's the procedure. It's pretty simple. Again, structural damage is going to be very rare, and you can respond to it if you need to. It might be a once-in-a-lifetime kind of an experience. All right? Are there any questions on that topic?
How many takes did that photo?
That was a one-off, and I don't even know how it got found. I mean, you know, it was in the folder. That's the Art Institute. By the way, this is downtown Chicago, so that's the Prudential building. It's kind of a, you know, people from Chicago would recognize it, but that's Millennium Park. But now that was a one-off kind of a thing. Yes, sir.
Do contractors ever ask you before they did a project to do some like preliminary investigations to see if that's going to change their means and methods to a project?
Yeah, no, really savvy contractors doing a large job, I think, would. And I'm trying to remember cases where we've been approached. Do you guys, Nate or Bob, remember a case where the contractor has been on very large projects, and you guys might have encountered this. Let's say they're building a big stadium, or you're building a big, well, even a museum. Oftentimes there's a contractor engaged during design, right? Pre-design services, they call it, or pre-construction services. Those contractors are really thinking early on, how can we do this smarter, better, you know, cheaper? And so,
burn in the past, right?
Well, that's,
got that kind of seared into them.
Well, that's what I'm just,
well, that's true, yeah.
that's what I'm just wondering if they do a project, assume they're going to be able to do it a certain way, and then we set up the monitoring and find out, hey, they can't do it the way that they do it.
Yeah, we're working right now for Turner on the new Caterpillar headquarters in Peoria. It's not a secret anymore, I can say that. I don't know when it's going to kick off, but Turner is using us extensively to try to avoid, really their risk is schedule delay with a huge project like that. So they're thinking, how can we avoid exceeding the limits and disturbing the neighbors on a big project by engaging you? And so we're helping them, we're doing some trials and things for them in advance. So that's an example. Yes?
So, you know, in that example you gave, that there had been some damage that are caused by the contractor. In certain cases, would you allow the contractor to do the repair? I mean, if it's a historic structure, would you want him, or would you say he's liable, he's got to find somebody to fix it?
Yeah, absolutely. No, you don't want
I mean, if it's...
Joe Smith, you know, Mason out there fixing Frank Lloyd Wright's masonry. So, in the specifications that we write, and I think you're protected in your construction manual because it says that the contractor has to repair the damage per OLE's instructions. Do you remember that? That's in the contract. Okay, so you've got ultimate control there. That's a perfect spec. In what we would write that's a little more detailed, we would lay that out, that they would have to provide submittals, there'd have to be review, you'd probably have to involve the State Historic Preservation, you know, officer, and that kind of thing. So no, you don't want to just say repair it to the pre-event condition. That's not enough. Good point.
Yeah, and part of that would be having someone that's qualified. Secretary of Interior standards would be something that we would require as part of that.